Have you all signed up in the classroom? Yeah. So I posted a story as the first link. Have you heard of the old man who lost his horse? No. So it's an old Chinese story. Story goes like this old man has this stallion. It's an amazing stallion, but it runs away and crosses the border into barbarian country, and everyone consoles him. So it's such bad luck, and he says, "Well, who knows if it's good luck or bad luck?" And then the next week, the stallion comes back and brings a whole load of other horses following him from the barbarian country, and he now has several horses, and the horses reproduce, and he becomes very wealthy. And they say, "Oh, you're really lucky." And he says, "Who knows whether this is good luck or bad luck?" And then one day, his son's out riding one of his new horses, and gets thrown off and breaks his leg. And again, they console him for his bad luck, and he says, "Who knows if it's good luck or bad luck?" And then the next week they go to war, and the barbarians are attacking, and every man who's of fighting age has to go and fight. So they all go off to war, and 9 out of 10 of them die. But because his son had a broken leg, he wasn't able to go to war, and he stays at home. And the man is spared losing his son, and he survives. And the story goes on, and it's effectively like the stories get nested inside each other, and the evaluation of what the story means depends on each new layer at each new stage. And if you're in this story, you're not aware of how it's going to change, but you're kind of locked in to the experience of now. Now, in the blurb, I pitched the course kind of, like I was saying to Oliver, kind of in between physics and philosophy, and we're going to cover some of the story of physics. But I want to highlight how that story is nested inside what our human story. So a lot of physicists will just do the physics, but not be aware of the story that they're nested inside, and the story that get changes in terms of there's revolutionary changes at each stage along physics, and there's an interplay of the actual physics and the bigger stories of society, and they kind of are an iterative process. And there's a number of ways you could write that story. So for instance, the old man who lost his horse, you could write it as a pessimist and say, look at all these bad things that happened, and they happened. But then you could say, well, that's actually fortuitous all along the way. And the point about the bigger story is that one narrative isn't big enough to contain human experience, and certainly not the physics and cosmology of the entire universe. And I want to, as we go along, we'll go through the story of physics and explore some of the A-level stuff and then beyond, and then look at how that's been framed at the time and how we frame it, and question, okay, how is that just a limited perspective, or is our framing just too narrow? How else could you frame this? And just to set you up so that when you go into university, you're aware of the framing that different people will give you, because everyone is nested inside a story, whether they're aware of it or not. And becoming aware of the story you're nested inside is a bit like waking up. And I wanted to do that with physics. For physicists, everyone has that personal story about asking questions that drive you to ask the question why. It's not just you're a human being in the lab doing something, you're doing it for a reason. And as well as looking at the information, I want to look at the reasons why, and the answer is why, potentially. Okay, I'm going to plug a number of books while I do this. Simple starting book, Big Bang, very good summary, covers a lot of the A-level course basically in a narrative form, okay? And it describes the people, the history, the interplay, and you can see a lot of the big ideas go backwards and forwards. I have printed out some notes for this, or back. If I zoom in like that, is that good?
Yeah, that's good, thanks.
Right. So these are notes taken from Simon Singh's book, The Big Bang, and it covers basically the A-level syllabus in quite a nice, engaging narrative way. And I just want to look at draw out some of the things and go into how the story has changed and maybe challenge some things as well. Okay, so Simon starts with the myths, okay? Explained everything in terms of gods and monsters. And then we have proto-science emerging, he says, with the Greeks. Obviously, this is going to be a pared down story. There's lots of other cultures as well who had proto-science and explored stuff. Alchemy was a bit like the dream that had to happen to start understanding the world before science emerged. But I mean, the Greeks had massive contributions. They also obviously had myths and gods and monsters, but they also started thinking in much more structured ways and developed kind of natural theology, the study of the natural world, as well as in this kind of mythic structure. Okay, and they were also able to do a lot of measurements. They knew that the Earth was round. They had measurements of the size of the Earth. They had a number of ideas that were false, that were based on philosophical ideas. So they had an idea that the Earth was at the center and the planets moved in perfect circles. So Ptolemy's Epicycles, the circle was a perfect shape. As a philosophical idea, this was the start of using mathematics to explain the universe. And Ptolemy's cycles worked for thousands of years to explain where the positions of the orbits were. So you would have an orbit around the Earth, or a circle around the Earth, and then another circle orbiting the circle, and that could explain things like the retrograde motion of the planets. Well, it could describe the retrograde motion of the planets, and was incredibly accurate, actually. Okay, then we have Copernicus. He had read about the heliocentric theory of the universe, and people favored either the Earth-based cosmology or the heliocentric model for different reasons. So there is a story, and the one that Simon Singh goes for is that we're not at the center of the universe, and the story of us going from the center of the universe being the Earth to the center of the universe being the sun, the center of the universe being the galaxy, is a bit like mankind being dethroned. But not everyone saw it that way. So people who favored the heliocentric model, for instance, in antiquity, did so because they worshipped the sun god, and then the sun was the center, and that fitted better with their philosophical system. When Kepler came along, he saw, well, a lot of the medievals saw the Earth as basically being the sump, the bottom, the dregs of the universe, and then you have the heavens stacked up on top until you get highest heaven on the top. But the shift to the heliocentric model suddenly elevated Earth into the heavens. So there's a number of different ways to frame the story and talk about what direction you do, whether this is the triumph of science over the inflated ideas of man being the center of the universe, and we're waking up to the idea that everything's meaningless, or about finding our true place in the heavens. And Simon Singh frames this story all along the way, if you see his framing, as the triumph of science, the depersonalization of this mythic structure that we previously, historically, were embedded in. And this is a kind of glorious story. But there's other ways to frame that story. And certainly the people involved in this story didn't necessarily frame it like that. So Copernicus, the thing that drove him, his reason to be, was to know the mighty works of God, to comprehend his wisdom, majesty, and power, to appreciate in degrees the wonderful working of his laws, Surely this must be a pleasing and acceptable mode of worship to the Most High, to whom ignorance cannot be more grateful than knowledge. For him, the story was discovery. The process of discovery was an act of worship, and it elevated human beings to know these truths. It elevated them in their purpose, and the data itself was in some sense holy. Okay, so there's different ways to frame the story. Looking at Simon Singh's framing, so you get the reasons it wasn't accepted. So he was virtually unknown. His model defied common sense, so it was against the flow, what everyone knew to be true, the worldview that they were in, it challenged it. This is the most interesting one to me, though. His model was less accurate than Ptolemy's. This one is kind of skipped over by Simon Singh, and this one kind of gets more emphasis, okay? So religious and scientific orthodoxy quashed original thought. I think that's a bit of a stretch when you look in more detail at the history, partly because Copernicus was orthodoxly religious. His exploration of it was religiously motivated. So that's the story framing, okay? This, in terms of what happens in actual science, I think is much more significant. If you've got a less accurate model that is less useful for predicting exactly where the stars are, you wouldn't expect it to be universally accepted. Okay, but there was something that this model had that was true that the other model didn't have, and then we have a number of others came on to develop this. So we've got Copernicus models was improved by Kepler using Tycho's observations. In fact, the first thing that Kepler did was actually to fix Ptolemy's theory of epicycles. So if you move the central circle, so you've got a circular orbit that kind of moves slightly around the Earth, you can actually map up the results better to what's observed. And it was only because Tycho Brahe's observations were so accurate that Kepler started to know, actually, this is a very slight difference that oscillates. Well, first of all, by fixing Ptolemy's model, he had a better mathematical map to the data, and that map showed him that there was underlying patterns that were the same for every planet. Obviously, that was because the motion of the Earth around the sun was kind of being projected onto all the other planets. So if you look at in detail at the orbits of all the other planets, you could see that there was a next thing he was able to do, because that new model was to see that there was actually, although his model was more accurate than Copernicus's one and Ptolemy's, there were slight differences still between the new data that he had from Tycho Brahe, which was incredibly accurate down to minutes of an arc. Yeah, Joe.
Sorry, what was that word? Data from
Tycho. So Tycho Brahe was okay. So Tycho Brahe, Danish nobleman, astronomer, known for his accurate and comprehensive astronomical observations. Really, really meticulous. And it was only because his data was so good that Kepler was able to use it to show there was a slight difference that showed that elliptical orbits fitted better than these shifting circles. And all these guys would have been astrologers and alchemists as well. That's what science was at that stage. It was alchemy, astrology, kind of waking up from the dream. We've only got 5 minutes left. We'll go on to Galileo. So Galileo championed the sun-centered model. So he started doing his own observations. He got a telescope. He showed that Jupiter had moons, that Sun has spots, and Venus has phases, which contradicted the perfection of the Greek philosophical system, and showed that something else was happening on Venus. Very much supported the new theory of the heliocentric model. Now, here we're looking at, again, at the framing of this story. So Galileo wrote a book explaining why the sun-centered model was correct. Unfortunately, the church bullied Galileo and forced him to recant in 1633. If you dig down into the history in a bit more detail, it's a lot more complicated than that. For a start, Galileo was a believing Catholic. He was very much in the frame, like Copernicus, of doing science in this cosmological worldview of ultimate meaning and God being the creator. And also to frame it as him as this kind of secularist against the church is not accurate either. There were many Jesuits who supported him. The church had actually honored Copernicus in the past as a mathematical model. It was to be explored. And also, Galileo's argument didn't line up with the data either. He argued against Kepler even about tides. Kepler said the tides were due to the moon. So Galileo had a theory of the tides, and it was basically the Earth sloshing around. But his argument led to the prediction that there was going to be one tide per day, and everyone knew that there was two tides. So the idea that he was just so in the right that the opposition he faced, whether it be scientific or philosophical, was just because of entrenchedness. It's just not correct. Also, when he wrote his book, he had many discussions with the Pope. He was a good friend of the Pope. He had patronages. He was well supported by the church. But then in his book about the discussions between the two positions, he wrote a main character who was arguing for the position of the Earth-centered model. He called him Simplico, the idiot, basically, and framed him as a caricature of the Pope. So politically, he was a bit of an idiot. You don't call the most powerful man in Europe an idiot. Politically, he made some very bad steps. And also scientifically, everyone could see some of his arguments were incorrect because obviously there are two tides. We'll carry on a bit with the story as it covers the A-level stuff. And then we'll carry on, look at the Big Bang, and then beyond, what stories is the story of the Big Bang nested within. If you've got any questions, comments, just stick them in the classroom, get discussion going as well. I'm very happy for you to push back, challenge stuff, ask questions, explore. I want this to be useful for your thoughts. Okay? Okay, Archie.
Sounds good. Thank you, sir.
See you on Wednesday.
Cheers.